Hello, astronomy kids. I want to explain the second astronomy final exam question to you. This is why did Aristotle, and really by representation, Greek astronomy, which was more sophisticated than we give it credit for, why does the Greek astronomers think that the Earth was geocentric, was in the center of everything, and that everything moved around us? Did they have some good reasons? Well, for you and I, you might say, well, it doesn't feel like the Earth is moving. They went farther than that, however. They used those three basic ideas in Greek science to say, well, what if the Earth moved? Let's model that and see what it would look like if the Earth moved. So here's one of their great reasons for saying the Earth did not move. Because they did not find, notice what this says, they did not find any evidence of stellar parallax. So parallax, if you hold a finger outstretched and put it over a point and swap eyes, the finger seems to move. That's parallax. When you change your observing point, something nearby appears to move against the background. We use parallax in video games, so you can tell you're moving in 3 dimensions, in that the bushes near you are moving fast, the bushes further away are moving more slowly against the background thing. Parallax, you use it all the time. So consider what would happen then if this was the sun here, and this was the Earth 6 months apart, at the opposite sides of the sun, and this is a nearby star. Well, if that's a nearby star, when the Earth is at this point, and we're looking that star now, we're looking at that star should appear here against the background stars. 6 months later, when we're over on the other side of the sun and we're looking at that star, now that star should appear here against the background stars. That never happened. We never ever observed any stars, some of the bright ones that probably would be closer to us. We never observed, even though we looked hard, we never observed them move at all against the background stars. Now that can only be if one of two things. One, we're geocentric. The Earth does not move. Everything moves around us. Then that works with the model that no nearby stars should appear to move against the background stars. The other reason they never suspected, we have a lot of trouble imagining it, and that's if you took the sun as the size of a marble, a little marble, and you tried to scale the universe down to that, well then where is the next nearest marble-sized star? Is it a mile or two away from us? Turns out, the next nearest marble-sized sun would be 160 miles away from us. That's the next nearest marble-sized sun. So we can't imagine that. The Greeks certainly could not imagine that the stars were in fact so far away that the nearest ones, even though they are moving because of stellar parallax, they would move in such a tiny amount you would need a modern day telescope to observe with photographs to observe such motion. Having no access to technology like that, they had to rely on naked eye observation, and they would never see stellar parallax. So the Greeks were really smart when it came to proving that the geocentric model must be correct. They simply had no imagination, and I must admit to not having quite the imagination to imagine how far stars actually are. They couldn't imagine that stars would be so far away from us as to have that happen, that even though the Earth is at opposite sides of the sun, you still don't see the nearby ones move against the background stars. So the ancient Greeks had very good reason to conclude that the Earth must be in a geocentric situation and everything is orbiting around us. Okay? There you go. Lack of stellar parallax. That's answer number 2 on your final exam. Okay, so you need to explain it like that. I would put in some detail, and the failing of it was that all stars are unimaginable. far. And they really are. They're so far. Even though this works, the amount of stellar parallax we see for any of them can only be measured in using photographic methods. There you go. Thanks for watching.